Okay, so to do our technology, there's a couple things. The first thing is we're going to be able to use the change of base formula. So looking at that, I know I have some numbers in here, but we're starting off with log base a of some argument m. And it turns out that what we can do is break this up into two different logarithms and divide it. Notice my new base is base b, so I went from base a to base b. And then upstairs, I'm taking the log of the new base of what I was taking of the old base in. And then on the bottom, I have the log base b of the old base. All right, and so this allows us to change things up. Now, I kind of disagree with where the book's putting this because this actually makes sense when we start solving equations in a bit in 6.6. So we'll just use it, and then the proof of this is actually going to come in 6.6. So I wish they would have put it there, but we'll use it where we got it. So again, I kind of rewrote it over here. And this is very important because when we look at our calculator, right, the two bases that I have on my calculator, right, are the base 10 log and base e natural log. So when it comes to actually finding what is the log base 7 of 42, right, right now we can't do anything with that. But the change of base formula, you can use whatever you want. So if I use base 10, the change of base formula says that this becomes the log of 42 divided by the log of 7. So it's my new log, right, of what I was taking the log of divided by log of my old base. Of course, we could have used base e. If I use base e, this is the natural log of 42 divided by the natural log of 7. So again, the idea is my new base, take the logarithm of whatever we were taking the log of originally, and then divide that by my new base of the old base, right, base 7. So going to my technology and pressing buttons now, right, notice that they'll end up being the same thing. So if I take the log of 42 and divide that by the log of 7, right, what we get is 1.920782221, right? If I use the other base, the natural log of 42, and divide that by the natural log of 7, right, what I get is the same number, 1.920782221. So this, right, estimate is 1.920782221. All right, so there's an estimated value. Again, let's not lose sight of what we're doing here. What we're saying is if I took 7 and I raised it to the 1.920782221, what I would get is something very, very close to 42. That's the whole idea. Remember, logarithms represent powers that I raise the base to get that number. So I'm just kind of reviewing that old idea. All right, and again, we can easily verify that. Heck, I'll do that. All right, so if I took 7 and raised it to the 1.920782221 power, right, what I get is something very close to 42. And again, the reason why it's not perfectly 42 is because of the round off error, right? It's an estimate, as I'm showing you there. So there's your change of base formula. So base 3, right, of 36. Well, again, I can rewrite this. You use whatever base you want. If you want the common log, then we rewrite that as that. If you want the natural log, then we rewrite that as that. So our new base of what I was taking the logarithm of originally divided by my new base of the old log. All right, so either one's going to be the same. I'll go ahead and use base 10. So log of 36 divided by the log of 3 gives us an answer. Our estimate is 3.261859507. So again, this is the power that I raised 3 to get 36. All right, and so that's, I'll let you guys verify that. I'm going to keep working. Here's a tricky one, right? My base is pi, all right, of e. So how about we go ahead and since we have e, let's rewrite this as the natural log of e divided by the natural log of pi. So there would be my change of base. If you don't want to use base e, we can say this is the log of e divided by the log of pi. All right, so change of base, it doesn't matter what base we do, just be consistent. So let's go ahead and do that one on my calculator since I did the common log. So the natural log of e, right? Oops. So the natural log of e to the first power, right? So that's e there. We've got to be careful. And we're going to divide that by the natural log of pi, which is a secondary function over here. So second pi. And what we get is 0.8735. Just again to show you it doesn't matter if I took the log of e, again we're to the first power here, and I divided that by the log of pi, right, we get the same thing. So it doesn't really matter what you change it to, just be consistent. All right, log of 50, well, we don't need any change of base, right, because log of 50 is on my calculator, so that's nice. So we'll just do the log of 50, and we get this to be 1.698970004. Okay, so there would be that estimate. Again, no change of base needed. That's a logarithm on my calculator. We just use it. 7 natural log of 2, we'll just write it the way it is. Keep in mind we're talking about 7 times the natural log of 2. And so that would be 7 natural log of 2. So just type it in the way it looks. Of course, if you wanted to get a little fun with that, right, this is also the natural log of 2 to the 7th, right, using our rule of exponents that we did. So let's just verify that. So the natural log of 2, right, raised to the 7th power. All right, oops, I got that. Let me delete that, come out of there, and put my parentheses in the right spot. So what's the natural log of 2 to the 7th? 4.85. So we're kind of verifying our exponential rule with our calculator. And then here again we have the natural log of 3/4 over 5. So just type it in the way it is. I've got the natural log of 3 divided by 4. Close those parentheses out, right? And then we're going to divide that by 5. And so this looks like it's roughly negative 0.05753, yada, 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 right? Or if you want to, this is our natural log of 3 minus the natural log of 4, and divide that by 5. Just be careful with your parentheses. So I'd have to go parentheses, natural log of 3 minus the natural log of 4, right? Close those parentheses and divide it by 5. And I get the same answer. All right, so kind of verifying what we have. We can mess around with it or just type it in the way that it is. So we're either lucky and we have the keys on our keyboard, right, or we're unlucky and we have to use the change of base formula, and it doesn't matter which one you use, log base 10, log base e, just be consistent in how you use it. All right, so there's the technology with our estimates, and that pretty much gets us ready to do the big thing of solving equations. We are now ready to solve exponential and logarithmic equations like crazy. So we'll be doing that in the next section. So there's the end of 6.5. Big ideas on properties, when to use them, how to use them, and what to use them for. If you have questions, please contact me via email or see me during an office hour. Otherwise, keep posting your work on Canvas and give me an opportunity to grade things before you take your quiz. We are almost done, you guys, so finish strong, stay in the game. Talk to you guys later.